and welcome to Midland Public Library's Teen Makers. My name is Jennifer Whip and I am both your host as well as the Maker Place Coordinator here at MPL. Every Tuesday, I'm coming to you with a new incredible teen maker, creative, or STEM hobbyist. Today, we are super lucky to have Thomas joining us. Hello, Thomas. Welcome and thank you for being here.
Hi, Jen.
First off, I'm just gonna ask you, to tell me about you. What makes you a teen maker? What's your maker hobby or skill or skills?
Well, I am Thomas Battistini from Gravenhurst High School. I'm part of the local robotics team at our high school, and I just love making robots. That's what makes me a teen maker.
Yeah.
Do a lot of computer-aided design, a lot of electrical work for our robots, and I use a CNC router, and that's a lot.
So fun.
Yeah, that covers most of what I do.
Just the whole idea of robots, it sounds so like science fiction and futuristic, but to hear that you're actually, doing stuff with robots today is pretty incredible. Can you tell me more about your hobby and do you have any examples of your work that you can show us?
Yeah, so I mostly do computer-aided design, which is locally called CADing in our part of the world, just to make it a little bit simpler. And I can show you some renderings if you would like.
Yes, that would be fantastic.
All right, so first program that we've ever started off with is with a program called Onshape, and it's a free program for educational users, and that's what we use. This is a robot from 2 years ago. It's a full rendering of it, minus the electronics, because that would have taken hours on top of the work that we've done here. But you can see that we have a simple little drivetrain with 6 wheels, an intake device for challenge for our year. We're part of FRC, First Robotics, and we compete every year at a competition. This was our competition for 2019. If you search up firstinspires.com on whatever web browser that you're using, you can find loads of different sources. The Blue Alliance, that it shows all the matches that every single competition that's around. This is a worldwide competition. So there's teams from China, Afghanistan, Russia, England.
Wow.
Yep, think of a country and they most likely have a team.
That is cool, Thomas. How long do you think it took you to make this model in here?
This model?
Yeah.
It took about 60 hours.
I believe that. Yeah. That's incredible. What else you got for us?
Because as we change designs and we have to change the rendering as well and all the fittings and all that fun stuff.
Mm-hmm.
So the rest of it is some pretty simplistic stuff. It's not a big robot. But next we have a little shield from one of my classmates. It's a little Christmas ornament that we made.
It's very Captain America.
Yeah, it's a Captain America. So very simplistic, very nice.
Not only can you use this for making robots, you can use this for making Christmas ornaments. That's what you're telling me.
Mm-hmm.
Cool.
In order for us to cut out all of these lovely looking ornaments and gussets and such, we use a Laguna IQ CNC router. This guy here. So you put your sheet of metal, plastic Lexan, or maybe even steel, put it on what's called the fly table here, and then the router will just cut it out for you.
Amazing.
After you design it, of course. Here's a nice little simple gusset where you can put a bearing, and there's bolt holes so that you can mount it to whatever project that you're making. This is a rendering of a motor that I had for an exam once. So I took this drawing of it and I made this guy in about an hour.
Wow, really?
Yeah, I did it super quickly. Here's just some other renderings of it. Oops, not that one.
And I see this is one of those things with the more you're doing it and the more you're playing with the software and everything like that, like the faster you get and the more intuitive it becomes, right?
Oh yeah. Onshape was how I first learned how to do most of this rendering.
Mm-hmm.
It's a simple, complex program. So in the industry, there's a lot of different CADing programs, such as SketchUp and all that fun stuff. And those are very simplistic ways to CAD. This is on the higher end of the spectrum of, there's a lot more different tools and such where you can modify and cut out things as you please.
Cool, so it's a little bit more sophisticated, maybe not your beginner level software, but once you get it, you work your way up to it kind of thing.
You could.
Or you started with it.
Yeah, I completely started on Onshape. I did simple stuff, like made a couch, car, simple shapes. One time I made a dodecahedron with a friend. It was very interesting. And I can't get to that. There we go. And then this is just basically your beginner slate. You can choose whatever surface to work on. So I could go to the top surface here, open up a quick sketch, and make literally whatever shape I wanted and whatever measurements. And this is basically the starting platform at ground zero for any project.
Okay.
It's pretty stuff.
That's so cool, Thomas. Like, I would love if, if we had an infinite amount of time, I would love to just sit here and watch you design something, because I bet you it is just a really cool process to watch.
Yeah, I guess.
Yeah, fair. It's hard when it's your own work, right? It's like when you cook something and it never tastes quite as good as your mom's because you made it. It's one of those things where you're your own harshest critic. But like, I think it's just a really cool process, and it just has so many like real world implications for the things you can do with this. Like even just your examples that you've given us today, like you've already shown us like the different things that you can do with this software, and it's pretty cool.
And most of them, except for the motor, are all 2D shapes. They're all fairly simple, or what we call 2D. So they're made on a flat plane. But you can create lots of different 3D models, such as homes. They're starting to do that now. Our architects are using CADing software to make homes from scratch.
Wow.
From the studs up. So it's very interesting.
No kidding. That's cool.
So Onshape is your very basic level. Fusion 360, which is the next program that I learned, is a little bit more sophisticated. And then SolidWorks is a very sophisticated level of CADing.
Okay, and is SolidWorks like are these ones also free, or are those ones paid?
Oh, these ones are not free. I get Fusion 360 through FRC. They pay for the program, and then it allows everybody in the program to use it. So I can access this at school, I can access it here from my laptop, but it is definitely not a free program. If you go to school and end up using these programs, your school might end up paying for the program for you. It might be part of your tuition and extra costs, but it's a very expensive program. If any of you watch Game of Thrones, all of the Game of Thrones dragons are made on SolidWorks.
Whoa, that's a fun fact.
Yeah. All of their joints are mated with connectors so that they're all separately moved, and then they can do all of their animations in SolidWorks itself.
Hey, that's really fun.
The neat thing about Fusion 360 and SolidWorks is that they have integrated physics engines. So I could take this part, which I don't have installed on my computer because it's a very large program, but I could take, say, this gusset, and if I had 500 newtons of force here, it would show all the stresses within the gusset and where it would falter.
Oh, cool.
Yeah. There's wind tunnels for drag. It's really neat.
You can basically just put your designs through the ringer and really just test them in here.
Oh yeah. And that's what makes it super nice and why you can see a lot more of my projects here on the left side. It's because, say I wanted my climb hook, and we tested the physics to this. So this would go over a pole, and then our 150-pound robot would be connected with those 4 bolt holes, and then we would run the physics engine to see where it would falter first or next, and then continue trying to make it stronger. This is the final version, and it's a little bit thicker here than our first version, and so on and so forth.
Cool. You can basically go through this and you can adjust as you design in the program based on the tests that you're running.
Yep. Okay. And so you're able to infinitely tweak your design until you're happy with it, and it's super cool. So we got just a simple wall here for one of our blasters. It would take in an elephant ball, a dodgeball, and then fire it back out, and this was our guides for it.
Ah, fun.
So we would have 2 wheels up here in the front, which would just shoot it. And I'll show you some photos of this year's robot. We just don't have CAD rendering because we ran out of time. Mm-hmm. And then here's just another simple plate. This is all the CADing work. I can't show you any of the electrical work, sadly. I would love to. I love the electrical work. But yeah.
That's amazing. That's amazing. I'm just blown away by the work that you're able to do in these programs. Because I mean, I've dabbled in it and I play around a little bit with some of this stuff. And you're just so advanced. And how much time would you say that you've spent developing this skill?
I've been working on this skill for about 3 years now.
Yeah.
Because I can use a CNC router. Oh, didn't even explain what CNC was before. So CNC stands for Computer Numeric Control. So here, I'll show you something else. There we go. This is what's called a post-process. So these are all numbers that my Fusion 360 will print off on a notepad and just straight up numbers. And these numbers tell the router which direction to go, at which coordinate, at which time, how fast to spin the router, what bit to use, and all that fun jazz. And so these are all the numbers that our router will take in. Mm-hmm. So we don't have to do this all by hand, quite gladly.
Yeah.
So it will spit out these numbers for our cuts and such, and then we just put that to the router, and then each of these is a position. So it will go to, on the 300 process, it will go to X, Y, Z, right?
Yep, yep.
Much like, and then 3D printers are much the same, where they'll just take all these numbers and then they'll print from the ground up. Or
Yep.
with the C router, which is called subtractive machining, it will take away material from plastics and metals.
And so I know when you're working with 3D printers and things, you're working in STL files, and what kind of files formats are you working in these? And
we mostly use dot objects to send to each other because they're a little bit more stable when they're sent in an object. Mm-hmm. And then we save them as dot steps.
Huh.
They're called files. They're a little different.
Cool, I didn't know that.
Yeah.
You have I'm dying to see pictures of these robots.
Okay, so this is our robot right here. We're Team 6864, and we're in the middle of a climb with the Huntsville's team and the Jabberwockies, and these are just our basic robots.
How big are these?
The rules are different each year, so each of the robots are different. This is at about 3 feet tall, So they're not very tall.
Okay, but they look ginormous.
I know. In comparison, they look huge.
Yeah, like looking at this photo, I'm like, those look, okay, yes, there we go.
Here we go. There's a little bit more of a scaled photo. So this is our first year robot. That was our third year robot back there. There's all our electrical systems and pneumatic systems.
Yeah.
We got a lip. We were very beginner, very new when we made this. So this is a very small robot, and we had no idea what we were doing.
But you learn as you go, right? Like you.
Oh yeah.
Yeah.
We went from this very rookie-looking design to a very nice cut robot in 2 years with a CNC router, and we have our own room at the high school now. It's very nice.
That's amazing.
We started off in a custodial closet, a small little 4 foot by 4 foot room where we would keep our robot and all our tools. So, interesting journey.
Moving on in the world.
Yeah. I could show you a video of the matches.
Oh, that'd be cool, yeah.
All right, so I'm on the Blue Alliance. We're Team 6864. We were with Team 865 and Team 7614. Blue Alliance versus the Red Alliance. So
what is the goal right now? What are you guys trying to do?
okay, yeah, maybe I should explain the game a little bit. So, every year, it's almost the same. First 15 seconds of a match is what's called the autonomous period.
Mm-hmm.
So the robots run completely on their own without any drivers. And then after that, it's what we call the teleoperated period. So we have 2 alliance stations on the left and the right. Left being the Blue Alliance and the right being the Red Alliance. And that has what's called our control stations. So we have our laptop set up, and we have our controllers and joysticks in order to run the robot all set up. And then after the first 15 seconds, we run our robots. This over here, these are 2 goals for the Blue Alliance. And this is what's called a portal. And this is what allows our robots to go and grab these balls, which are called cells, pick them up, and then put them in the goals. And then at the end of the match, we try to climb on this teeter-totter. It's a little hard to see. It's a bad resolution. But then we climb the teeter-totter for more points.
What a cool competition. Where was this one held? I would love to come watch this.
This one was Georgian College. Yeah. In college.
How many people, like this just seems like a huge event. Like, do you know how, like, I know you said there's teams from all over the place. Do you know how many teams there are total?
Thomas was able to send me this information afterwards. There are over 679,000 students competing in the First Robotics Competition from over 110 different countries around the world. Incredible. Now back to the First Robotics Competition.
And now this is the teleop period. So we control all the robots from now.
Okay, so how long does it take to play, our, I don't know, do you call these rounds or?
So each round is about 2.5 minutes, but prep for each round is about 5 minutes.
Right, okay.
And we play dozens of rounds in a day, and they're called the qualification matches in order for you to qualify for the final teams.
Cool.
It's a very complex system, but once you know the system, again, it's very easy to remember.
Right.
So yeah, left side, bottom left side, that's our team over there, or was. So on the back right of our robot is that climbing hook. On the front of the robot is our intake using mecanum wheels. So it's wheels on wheels that are on an angle, so that whenever they run, whatever is linear will move on an angle.
Wow, these little guys, like these robots zip around pretty quick.
They can go faster.
Like how fast do you think? You know?
I could run a block on the street in 7 seconds.
Wow.
They're super fast depending on the motor that you use. So it looks like this game we were using defense because we were having problems with our targeting system. We were using a camera called a Limelight, which takes reflections off those targets, and then it will use an equation that we made to adjust for the height, the length, and create its own parabola within a couple seconds.
Okay, so this is the climb here.
Yeah, this is the climb. So imagine those 150-pound robots just climbing
What was that?
off of a couple small motors.
That's, I mean, mind-blowing, okay? The fact that that's what you guys put together is incredible. What type of tools and equipment do you have to use for all of this?
So I've talked about the Laguna IQ, the CNC router. We use a lot of different metalworking tools. So hacksaws, band saws, we have a small 14-inch metal lathe. Our first year, all we used was a hacksaw and a couple hand devices in order to bend and cut all of our metal. We prototyped most of our robot using plywood.
Oh, okay. Can I ask why?
It's cheaper than metal, and you can get most of the geometry off and your basic idea off, so that where you make it in the expensive metal, you're able to use it in the cheap scraps.
That totally makes sense.
So the time when we make a part on a robot, we make multiple different parts because everybody has their own different ideas. So we make multiple different parts, and then we just put them through rigorous testing before we make it into metal. Sometimes we skip out on the testing part, and then we make it in metal, and we screw up real bad. Like especially our first year, we didn't take any of that prototyping into consideration, and we, instead of using what we call an elevator design, so 2 metal boxes that get raised by cords, one's fixed, and then as you pull a cord, the other one will lift up. It's called an elevator design. We tried to do a scissor lifting design. So, kind of like a scissor will just open up upwards. Yeah. And it completely broke on us.
Oh.
Hours of making this thing and cutting by hand completely bent over and broke. So there's obviously the ups and downs of making things, and the more mistakes you make, the more you'll learn from it, especially the expensive ones.
Right.
And especially our first year, most of our materials were scrap materials from manufacturers around our town, and we would just take their scraps and use them for our own. Like the Muskoka Airport, we took a lot of their scrap metal.
Great idea.
Reduce, reuse, recycle.
Yes, I love that. So it's such a sustainable philosophy. Perfect. I mean, what I'm hearing from you, just based on your prototyping and learning from your mistakes, is that you really have to have a growth mindset and be willing to be persistent and kind of have that grit to hang in there and keep trying when things get tough, right?
And it surely gets tough. We make all of these robots within 6 weeks, right? We have 6 weeks to create a fully functioning robot for competition.
That is a fast turnaround.
After school, between 3 and 9 o'clock, we're there crunching, making this thing, prototyping all 6 weeks, and it's crazy. Sometimes we stay weekends, sometimes we would stay a little bit later. I would go about 4 or 5 times a week. It's nuts.
You gotta be committed.
Oh yeah, definitely committed, especially if you're doing the building, because if you miss a night, and you come back the following night, everything could have changed. Like, and started a new one, and you're still on the mindset of the old idea. Definite commitment there. But once you get in the flow and start making, especially our team, we just have such a positive mindset and such a positive atmosphere. There's music going, there's laughing, jokes, it's great. And that's just mostly the atmosphere of our team and just the wonderful people that I work with there.
That's amazing. I'm so glad to hear that you have that kind of community to explore this with, because it's incredible. And and I think it makes a big difference too about like helping you to remain committed when you have a group of people that you're working with. And just speaking of commitment, clearly you are, you're all in on this. So is there post-secondary programs or careers that you are hoping to pursue, or that people could pursue, that are in line with this?
So robotics is a very large field to talk about. And as you can see, I've talked about a lot of this stuff, and I still haven't even covered electronics, which is okay. I can go very in depth with that too, but we'll run out of time. So there's electrical engineering, mechanical engineering, biomechanical engineering, computer sciences, and then mechatronics engineering. And mechatronics is basically just combine all those different engineerings into one. You can't just choose. It's called mechatronics. That's the program I'm going to go to, that I've applied for university. Because I really couldn't choose between mechanical, electrical, and computer sciences.
So you'll just do it all?
Yeah, why not, right?
Easy peasy stuff for you.
A little bit of metal making, a little bit of electrical work, why not, right?
Oh, cool, Thomas. So who has inspired you during this journey? Like, are there people you look up to? Do you have makers in your lives? Where do you get your inspiration from?
In public school, it started off in public school.
Yeah.
There was this challenge first year that came to Gravenhurst Public School. It was the Sumo Bot Challenge. So all the public schools in Muskoka would come together, and we'd compete in what we call Sumo Bots. And so little Lego EV3 kits we would make, and we would participate in challenges each year. And that super inspired me, because I loved electrical work. I loved building, I love little technical things. So I decided to join the program because I wasn't part of any after-school club. I never really fit anywhere. But when that came along, that was just, it felt like it was built for me. So Derek Schofield, he's the teacher that brought it. He's a wonderful guy, good mentor. And I'm so glad that he brought that to our public school, or else I might not be here today. In high school, Dylan Hackmer and Mr. Gilbert, one of our math teachers, I don't remember his first name. David? Maybe. They started, or they began to start Gravenhurst Robotics team in 2016. Started in 2016, and our first competition was in 2017. That was it. And I've always been really good with math, and I always sat in front of the class in front of Mr. Gilbert. I swear I'm not a teacher's pet, but one day he just came up to me and he asked me, would you like to be part of robotics? And I'm like, wait, here? And I was really speechless for the rest of the day. And it was just, I thought we'd be going back to Lego or something. I didn't know that we'd actually be making things by hand. Neither did he, or that it would take so much time. So he got Iggy Van Kooten. He's our head of science at our high school. We got him involved, and he's been running the program ever since. So And Iggy's just also yet again a wonderful teacher and a wonderful mentor. So I have always looked up to Iggy and Derek Schofield.
It sounds like you're really lucky and like you've really just lucked out and kind of hit the jackpot with the educators in your life and the people that have been a part of your schooling who have introduced you to this stuff through school. Is there any like YouTube channels or influencers that you look up to just for kids who don't maybe have these types of programs at their schools?
So if you're looking for Canadian ones, the Hacksmith, he is from Toronto, and he's a most definite nerd, and he has a full team of engineers, and they're just lovely people, and they create, I would say, dumb stuff sometimes, but they also create very smart and genuine things. Mm-hmm. They also have this series called Make It Real, and it's taking things from Star Wars or from Marvel and then trying to make it real life, and it's really interesting. And they also just finished up with something called their Alien Power Loader series.
Okay.
So in movies, they made the Power Loader. And it was a very expensive project, but it's a really good watch if you're into this kind of stuff. If you're looking for another Canadian YouTuber, if you're more on the electrical side, there's Electroboom. He's a little silly, if I'm going to be honest. He's a Canadian electrical engineer, and he just creates the most stupid stuff. Like, it's hilarious to watch.
That's the best sometimes. The stupid stuff is often the best stuff.
Want to laugh? Go watch him. And also, he makes silly stuff, but he also talks about some advanced stuff. So careful with that. And then if you're looking for just another creator, Colin Firz.
Okay.
Colin Firz is from England, and he's just crazy. He used to be a plumber, and then he started up with YouTuber and just started making things, and he's been doing it for 6 years now. Mm-hmm. So he's been around for a little while, creating a lot of different crazy things.
Well, those are great suggestions. What about tips for people who are looking to get into this as a hobby? Like how should they get started? Where should they start?
That is a good question. I started off with Lego EV3. Mm-hmm. It is a very good place to start. Very basic stuff. You can just go search up Lego EV3. Mm-hmm. There's universities that even use them because it's introduction, basic level stuff to talk about and teach. And the Lego community has made, I believe, an educational program to go with it. So if you're really wanting to learn about the mechanical engineering side of things, then go check them out. Mm-hmm. If you're into CADing and that kind of stuff, I recommend Onshape to start with. Mm-hmm. It's free for education. If you don't have access to any of those resources, Minecraft. And if you get into redstone with Minecraft, I love redstoning in Minecraft. It's great. It's a great mind job because there's so many different things you can make. Like, people have made entire computers in Minecraft. Like, it's crazy to think that in a computer you can make a computer that has outputs.
That's a great idea, Minecraft. Like, and a fun place to start too. If you're just looking to dabble, like, kind of a fun place to start.
Definitely. You can create clocks and moving machines. Mm-hmm. It's just great.
Yeah, and like, speaking of that stuff, at Midland Public Library, we just got a bunch of Lego robotics kits, so people will have access to those soon, which is exciting. I know, right? And we have the 3D printer, and we have a laser cutter, and we have, so we have some basic software, like we have SketchUp and Inkscape and things like that. So people can come here too, use your library is one of those things I have to say. Use your library, guys. We have the tools. Okay, I guess to end it, is there any other resources you want to recommend?
If you go to First Inspires and read up about them, if you don't have a team at your school, maybe start one. We're always open to help you out here in Gravenhurst if you're wondering how to start up. Huntsville's team. They're very resourceful. They helped start us up. They're what's called our father team. And then they got started up from North Bay, which is our grandparent team. So, you know, be our kid and you can have a great grandparent team down the road.
I didn't realize that's the way it works. That's really fun.
Yeah, it's very interesting.
Yeah.
There's lots to learn. It is an amazing environment if you want to go into STEAM. Very energetic at competitions. It's so hard to describe how good you feel when you're at a competition. Even if you go all day and all you do is lose and your robot craps out and breaks all day, still amazing. And there's a term I'd love to tell you guys called gracious professionalism. And it happens all the time at first. And so say something on your robot breaks, other teams will swarm to your 10x10 pit to help you out because they want to beat you at your best. And it's just so amazing.
Wow, what a great competitive environment to be in where it's both competitive and cooperative. Like, I think you can't ask for more.
Like, you want to win, but you don't want to win while another team falters.
Yeah.
Because it makes them feel bad, and that will make them feel better if, you help them out.
Yeah, you want your win to be earned and deserved, and you want to beat them at their best, right? Totally get it. Well, on that, just to end things here, I just want to thank you so much for coming and talking with us today. It was incredible having you on. Just a huge thank you for teaching us and sharing your time and expertise. I'll be back next Tuesday with another incredible maker teen. But for now, thank you, Thomas, and I guess I will see you later. Bye.
Bye.